Okay. The second thing from the Morgan law is that A union B complement is A complement intersect with B complement. Again, both of these two equality, you can just verify it by Venn diagram. The second thing is the concept of partition. Actually, let's talk about is the last. The next one I want to talk about is probability. For any event, you have probability of A is at least 0, which means probability of any event cannot be a negative number. It has to be at least 0. If somehow you come to the conclusion that probability is negative, you probably did something wrong. Next one is probability of A less than or equal to 1. So probability cannot ever exceed 1. If you got some number greater than 1, you also did something wrong. That it means you need to recheck. Next one is probability of an empty set is 0. And probability of the simple space is 1. There's also formula for probability of A union B. So this is a formula, and it makes total sense when you try to draw it out using a Venn diagram. Let's say this is set A, this is set B. I want to know probability of A union B, which is the union of these two circles. So how do I do that? I first take the first circle probability of A. I add with the second circle probability of B. But then I realized that in the process, I add this area twice, right? Therefore, I need to subtract that area. So this is what the formula means, and it should make total sense to you. The next one is probability of A union B union C. You would have is probability of A plus probability of B plus probability of C minus the probability of every intersection of two sets. And then plus probability for intersection of 3 sets. And this pattern can be generalized for any number of sets. Even if you have 4 sets, like A union B, union C, union D, then for the part that have odd number of sets, like 1 or 3, then you have plus. And for the part that have even number of intersections between sets, like 2 or 4, then you put a minus before it. Does this make sense? Do you want me to repeat the part for, I was talking about this kind of pattern can be generalized for any number of sets. For example, if you need probability of A union B, union C, union D, then what you can do is, could you draw another diagram for this? Yes, but it will be like kind of a mess when we have like lots of set. I can draw the 1 for 3. I can draw the 1 for 3 for you. Like I have A, I have B, I have C. Okay. If I want to calculate probability of A union B union C, which is the union of all the circle here, then what do? I first pick each circle. So I pick this circle here. I add it with this circle. And then I add it with this circle. When I add like that, do you see that this one got repeated? This area got repeated. Why is that? Because when you take A, you already got this part. But then when you add with B, you got this part again. So you have to subtract this part. Similarly, you want to subtract this part and then subtract this part. But then you realize that, oh, I subtract this part too many times. So I have to add it back in the last one. Does this make sense? For the A union B union C? Yes, and this idea can be generalized for any number of sets that you have. The key is if you compare these two formula for A union B and A union B union C, you will see that there is some part you have plus and there is some part you have minus, right? For example, you got plus for this one, and then this one. And what is the common thing that they share? They are the intersection of odd number of sets. Here you have one set, one, and you have 3. For the sets that have intersection of even number of sets, for example, this one, these, they are even, so you put minus. So this rule can be generalized. For example, if you want probability of A union B union C union D, you can take probability of A plus probability of B plus probability of C and D. You have plus because the set only has 1. And then you subtract the pairwise intersection, AB, AC, and then BC, BD, and then CD. And then you plus for 3 set intersection. And then you subtract for 4 set intersection. Does this make sense? Okay, how about everyone else? Does it make sense to you? Yeah, thank you. Next one I want to talk about is the concept of partition. Okay, let's say you have 3 sets, A1, A2, and A3. Let's say you have A1, A2, and A3. If the 3 sets look like this, we say that A1, A2, A3 form a partition of the simple space. So what characteristic do they have such that they form a partition? We can say that for any set A1 up to AN, they form a partition if they satisfy 2 conditions. The first one is that the union is a simple space. And second is they are pairwise disjoint. So let's check here. In this picture, we have A1 union A2 union A3. It gives us the whole simple space, which is the rectangle, right? And then I check the pairwise disjoint condition. A1 intersect A2. Is there any overlap? No. So they satisfy it. A2 intersect with A3. Is there any overlapping? No. So it's satisfied. Similarly for A1 and A3. So each of the 2 sets are pairwise disjoint and their union is a simple space. Therefore, they form a partition of the simple space. An example when they don't form a partition is something like this. So in this example, their union is a simple space, yes. But A1 and A2 are not disjoint. Therefore, they don't form a partition. Or you can have something like this, A1, A2, A3. Now they are pairwise destroyed. However, their union does not form a simple space. Therefore, they do not form a partition as well. Does this concept make sense? Okay, and the reason why we want to talk about partition, because it makes our life really easy if you have a partition. Let's say you want to calculate probability of B. This is a set B, right? What you can do is calculate this part, which is probability of B intersect with A1, plus this part, probability of B intersect with A2, plus this part, probability of B intersect with A3. If you add those three parts together, it will give you probability of B, and you don't need to subtract anything. For example, if you have the B here, you cannot really do that. You cannot take probability of B intersect with A1 plus probability of B intersect with A2 plus probability of B intersect with A3. If you do that here, it will not give you probability of B because you count this part twice. However, if you have a partition, it comes out really nicely. That probability of B is just probability of B A1 plus probability of B A2 plus probability of B A3. And you can generalize this if you have A1, A2 up until AN form a partition. Then probability of B is just probability of A1 intersect with B, A2 intersect with B, up until AN intersect with B. And you can write it with a summation like this. And the same go with cardinality of B. It would just be cardinality of BA1 plus cardinality of BA2 up until BAN. Then this would be cardinality of BAI for I range from 1 to N. Does this make sense? Any question about this one? If no question, I will let you work on question 1, maybe for 3 minutes, and then I will take it up. Let me know if you have any question. Okay, what did you get for part 1? I exclude B is equal to A. What is the relationship between A and B? If this hold true. The good thing with this question is that it only involves 2 sets, right? And there are only few possibilities that can describe the relationship of the 2 sets. The first one is 2 sets are disjoint, so they don't have any overlap. Second is they do overlap, but how do they overlap? This one is like they overlap at some part, but then there's another part that they don't share in common. Next one is B is completely subset of A, or A is completely subset of B, or A is equal to B. I see a student say B is an empty set. How about everyone else? What do you think? Okay, we have to be careful about this. It is not like number where 2 minus x equal to 2, then x equal to 0. It's not something like this. So we have to be careful. If you look at each case here, you have A exclude B. It's just this one, right? And it is equal to A. And if you test it for any other situation, for example, this one, I exclude B is this part, but it is not A. So if you test it for every other part, you will see that it does not hold true. So the answer here should be A and B are disjoint. How about this answer? Is it wrong or correct? The answer is that if you answer like this, it will be incorrect because it is a stronger result than this one. Like this case, it covered this case. But if you just have this information, you cannot really tell that B is empty set. B might not be an empty set, right? It can definitely be some set like this. And then A is just mutual, like destroyed from it. Then A exclude B is definitely equal to A. Analogy for it can be something like, okay, if you see some animal, they say male. The only thing that you can imply from that is that animal is a cat, right? But you cannot imply that the animal is a kitten. Does this make sense? Like imply that is a kitten is a stronger, like it need more information than just the south male. And similarly here as well, you need like further information to actually conclude that B is empty set. With this information only, you can only conclude that A intersect B is an empty set. How about the second part? A exclude B is equal to B exclude A. The elements are in A but not B is equal to the elements in B that are not in A. Yes, but what does it mean in terms of how does A and B relate to each other? Are they disjoint? Or like they do have some common in like some element in common, like partially, like this one? Or is one is the subset of the other, or they are the same set? What do you think? Yeah, they share all the elements, right? Because if you look at this, A exclude B in this circle, B exclude A is this one, and they are not the same. And you can do that for any of the case here. You will see that they are not the same. The only situation work is this one. So we can say that A is equal to B. But be very careful. Like the question I did in TUT0101, they have some kind of inequalities. They have some kind of equality such that it matched with two of the picture. I think it was matching with this one and it was matching with this one. However, the only correct answer is this, because it is the same situation that in order to reach this, that question need like a further information. Could we have made an assumption for 2 because it's commutative? What do you mean by it's commutative? Like A exclude B in general is not the same as B exclude A. They are set operation. They are not really like some number subtracting. If they give you some equality, just go with it. Don't impose any further information. And if you see that two picture match, for example, if you see these two match, you should go with the more general one. Similarly, like this one and this one, if you see that both of them match, like what you are looking for, you should go with a more general one. Yeah, I feel like the minus side is a bit confusing. Normally, I use this side. Any other question about this one? If not, I will let you work on 2, and then I will take it up. Some important thing you might find useful for 2 is that A intersect with A complement is an empty set for any set A. And then A union with the intersection is just A union B intersect with A union C. Or like A intersect with a union is A intersect with B union with A intersect with C. So those are something that you might find helpful. I will give you some minute to think about it. When they see they write like A prime like this, it means that A intersects with A prime. I think in the textbook, they didn't really use this symbol. They just like kind of write two sets next to each other. Anyone got the first question? What do you get for it? AB union with AB equal empty set. Let's see. So this one, we can use the De Morgan law. They just AB prime, right? And then union with AB. Is this equal to an empty set? Yeah, it's union. So what should it give you if it is union? Yes, it should give you the whole simple space. Be careful. The intersection give you empty set, but the union will give you the whole simple space. What about 2? What do you get? How do you start for the second question? Is this term special? Yep, that looks correct. So this one is equal to A union B prime. So I have this one turn into this by De Morgan's law. And then I have it intersect with A union B. If you think of this as some set, so you have some set complement intersect with that set. So it is in the situation like some set intersect with itself, then it should result in an empty set. Does this make sense for everyone? Let me know if you feel confused at any part, because these questions are really important. If there is no question regarding that, I will let you attempt this one. So you want to show that some set is a subset of the other. And if we recall it, we have A is subset of B. And what does it mean by that? It means that if there is an element that is in A, then that element has also been in B. So we want to show this for every element in this set. If you can show that for every element in the set AC, that element is also in the set BD, then this set would be subset of BD. Does this make sense? Yeah. So I will leave you time to think about it. What you should start with is, let's say, pick arbitrary x in AC, and then you will see that what does it mean by x is in AC, and then through a bunch of steps, finally you will reach to that x is in BD. And it would be the end of your explanation. So I will give you some time to think about it and I will pick it up. Anyone got this? So if we pick arbitrary element X in the set AC, then what can you tell about X? Yes. So we have X is in A and X is in C. Right? Because if you think about it, if you have to set A, C, if X is in AC, which is this part, the intersection, then it means that X is an element of this circle and X is an element of this circle as well, right? And then what can you tell from X is in A and X is in C? What can you tell? Yes, that's right. So you have X is in B and X is in D. Why is that? Because we have two conditions. The first one is A is a subset of B. We know that A is a subset of B, which means we know if something is in A, then it has to be in B. And the second piece of information we know is that C is the subset of D, which means if some element is in C, then the element has to be in D, right? So here you have x is in A, which imply that x is in B. And then x is in C, imply that x is in D. And then we have x is in B and x is in D. So where is x? X has to be at their intersection, right? Does this make sense? Okay, if anyone find it confusing, you can like private message me. If you are shy, it is fine. If you're good with question 4, I will let you do question 5. How would you do it for part 1? One of the tools that you might find useful is Venn diagram. I don't know if professor accepted as like the way to prove something in this course. Last semester, yes, last semester you can use Venn diagram to show something is true. But I don't know about this semester, so you should ask the professor about that. So let's say we have 3 events, A, B, and C. And then we have A intersect B is an empty set, which means we know A and B are disjoint. And we want to show that AC and BC are also disjoint. Let's see, I have the set C. Then AC is this part, BC is this part, and they don't have any common element, right? Therefore, in the Venn diagram, they look disjoint. Another way you can do it is look at what is AC intersect with BC. And here we can use like if you have AB intersect with CD, then it turns out to be just A intersect B intersect C intersect D. Or if you have A union B and then union C union D, then you can just remove the bracket and union everything together. So in here, I would have A union C, union B, and union C, right? And it turned out to be A union B, union C, sorry, intersect C. And the first one is disjoint set, intersect with C, and it becomes an empty set. Sorry, this is empty set, which means that AC intersect with BC equal to an empty set. Therefore, AC and BC are disjoint. So that is the first thing we know. The second part, we want to calculate this probability. How would you go with doing it? So I want probability of A complement intersect with C complement, and then B complement union with C complement. How would you start this? If you can use this equation, if you can use this formula without proving it. Is there any special about those terms? When you see like two set complement union with each other or intersecting with each other, you should think about some rule. What is A complement union with C complement? What is it equal to? Yes, AC complement, right? And notice that we are trying to write in terms of probability of AB and AC. So we kind of want to make the term AB and AC to appear, right? We don't need anything like A complement and C complement alone. So I can convert the first set to AC complement. What about the second set? What is B complement union with C complement? Yes, BC complement. So do you see that it looks like this formula? It is probability of some set complement intersect with another set complement. So here, this, oops, I mean this one. This A complement is matched with AC complement. And then B complement is matched with BC complement. Then what we have is probability of AC complement plus probability of BC complement minus 1. And then probability of AC complement is just 1 minus probability of AC. Does that make sense? And then for this one, you have 1 minus probability of BC. And then minus 1. I'm not sure why they want to be in terms of AB and AC. It looks like BC to me. And here you would have 1 minus probability of AC minus probability of BC. Wait, what does that last step show? Do you mean this one? Like this one here?
No, I meant the one below it. Like the 1 minus probability of AC, and then everything from there. Just like the last two steps. The last two steps.
I'm confused. I'm not sure which last step you refer to, like this one or this
That
one.
one. That one. Yeah. The second one you highlighted with the arrow.
To go from this
Yes.
to this, I just use the formula here. So I match this A complement with the AC complement and B complement with BC complement.
Okay.
So instead of A complement, I put in AC complement. Instead of B complement, I put in BC complement. So that's all I do.
Okay.
And then
okay.
I use the formula where we have probability of A plus probability of A prime is equal to 1. So we have probability of A prime is 1 minus probability of A.
Oh, okay. I
So
get it
this
now.
one turned to 1 minus probability of AC, similar to this. And then I have 1 plus 1 is 2, minus 1 is 1. And then I have minus this and minus this.
Okay, I
Any
got it.
question about this one? If there's no question, I will quickly go over 6 so that you have the solution for it. So here we have Sandra drive back home and she have to pass through 2 traffic lights. There is a probability that she has to stop at the first traffic light. The whole circle is 0.35. And then the probability that she has to stop at the second traffic light is 0.4. We want to find the probability. We also have probability she does not stop at any traffic light is 0.5. So this is the probability she stopped at the first traffic light, second traffic light. If she stopped at none of the traffic light, it should be everywhere outside the circle. And it is 0.5. We want to know probability that she has to stop at both of the traffic light, which means we are interested in this one, right? And how do I find this area? What I can do is take this circle, add with this circle, and then subtract this area. Basically, what I'm doing is I use probability of first union with second is equal to probability that she stopped at the first traffic light and probability she stopped at the second traffic light minus probability that she had to stop at both traffic light. And I'm interested in this quantity, which means I have probability that first and second is equal to probability of first plus probability of second minus probability of the union. So probability of this circle is 0.35. Probability of this circle is 0.4. And then probability of the union is this part, right? And I can find this area by taking the whole rectangle, which is 1. Subtract everything outside the 2 circle, which is 0.5. So I would have 0.75 minus 0.5, which give me 0.25. And if they ask you to find probability that she stopped at exactly 1 traffic light, then you would have to find this area plus this area, but not include the purple part. Any question about this one? If no question, then it's the end of our tutorial, and good luck on your quiz.